Lesson 33, Applying Counting Principles. So there are two principles that we're going to talk about today. One is called the addition counting principle. The addition counting principle just says, suppose a trial can result in any of n sub 1 outcomes from one category, any of n sub 2 outcomes from another category, and so on. If there are k different categories of outcomes, the total number of outcomes that can result is n sub 1 plus n sub 2 plus, and so on until n sub k. That is written in your book, so we're not going to write out the entire definition for the addition counting principle, but we do want to say that it's only used for mutually exclusive events. So a mutually exclusive event, or there's two events, are mutually exclusive if they have no outcomes in common. So to find the number of outcomes in an event that consists of mutually exclusive events, this is when you can use the addition counting principle. So example, if you were to draw an ace or a face card by drawing a card at random from a standard deck. The ace and face card are mutually exclusive. There's 4 aces, 12 face cards that are not aces, so you could just do 4 plus 12, so there's 16 outcomes altogether. Or if you were to like roll a dice and then flip a coin, those two are mutually exclusive. So if you had, there's 6 outcomes on the dice and 2 outcomes on flipping a coin, so 6 plus 2, that would be 8 outcomes total for rolling a dice and flipping a coin. There's also what's called the fundamental counting principle. And it's written in your book, and it says, suppose k items are to be chosen. If there are n sub 1 ways to choose the first item, n sub 2 ways to choose the second item, and so on, then there are n sub 1 times n sub 2 times all the way up until n sub k ways to choose all k items. So, for example, a student is choosing a 4-letter password. So let's just put down here 4-letter password for like an email or something. How many passwords are possible if letters may be repeated? So we would just do, well, for the first letter, there's 26 letters in the alphabet. The second one, 26. You would have to times 26 times itself 4 times, or 26 to the 4th power, and we would get 456,976 different 4-letter passwords that this student could choose. That's just the fundamental counting principle. 2 events are independent if the probability of one event is not affected by whether or not the other event occurs. So 2 events are independent if the probability of one event is not affected by whether or not the other event occurs. So in other words, if I am spinning a spinning wheel with different colors on it, to spin it twice would be an independent event, because the first event you spin the spinner and you get a color, and you spin it again, and it's possible to get any of the colors again. So it's independent. It doesn't matter the second time you spin it what you got the first time. Two events are dependent if the probability of one event is affected by whether or not the other event occurs. So they're dependent if the probability of one is affected by whether or not the other event occurs. So two dependent events, for example, if you choose two cards that are face down, one is A and one is B. So what's the probability of choosing A and then choosing B if the first card is not replaced before the second card is chosen? So it's like one of those ones that we talked about before. So it's dependent. So you choose A first, and then in order to choose B second, you have to have A first. And it's like those ones that we used to talk about with the marbles. So if you take a marble out of the bag and leave the rest in and you don't replace it, then it changes the probability of the next time you draw, and that makes it a dependent event. Okay, that's the end of the lesson.